Hey, it's Shukra.
And Tim the Russian. We're doing a project on physics, and physics is the study of matter and energy and their relationships in the world. Physics is everywhere you see. Gravity always affecting us. The force is constantly bringing everything to the center of the planet. You can see physics in your car. Momentum, mass times velocity equals momentum. The faster you bring your car, the longer it'll just keep going and going. When you're playing any sport, volleyball, gravity's always affecting you there. You got top spin when you're playing with a ball. That'll bring a ball, down to the ground. Or with frisbee, there's Bernoulli's principle. When you throw a frisbee, the velocity of the fluid of air is above the frisbee, it increases, and the pressure decreases. So the pressure below the frisbee increases, which causes it to stay in the air. And, let's quit it at that.
Attaboy, Tim. As you can see, these are the Lobo Lions. We're currently on a 9-win streak and have clinched the playoff since first time in ever. That's my boy Kevin Borwick hitting it. To you, Timmy.
Alright, so in baseball there's lots of physics. You got a projectile, which is the baseball, thrown and hit by the baseball, gives it projectile motion, it gives it a trajectory, and if you have the velocity and the angle at which the ball is hit and the distance it goes, you can figure out the velocity of the ball with the range formula, which is initial velocity, or projectile velocity squared, times 2 of the angle, sine of 2 of the sine angle, divided by the force of gravity. And that'll give you the range of the baseball that'll go.
Hey, Timmy, carry me, man.
Oh, Jesus. You're so heavy, Shukra.
Dude, that messed up. I thought we were going.
Dude, there's a wheelbarrow. I don't need to carry you like this. Come on, man. This is a simple machine. This, you see, is a wheelbarrow.
What a wheelbarrow is? Wow, impressive.
We got 2 simple machines here that give us a great mechanical advantage. We got a lever and we got a wheel and axle. I can even push them off this inclined plane. Woo! And it's so much easier because I got simple machines. Way easier than giving me a piggyback ride, Shukra. Yeah.
How long did we get that? Hey, it's Shukra. My friends Alex Francisco and Timmy Zalave are playing frisbee. And Timmy told me frisbee revolves physics, but I have no idea, so I'm just going to have him explain it. Alright, peace. I gotta look.
Go.
Yo, Timmy, which one do you think weighs more, the baseball or the golf ball?
Definitely the baseball.
So does that mean the baseball will drop quicker? Since Walsh doesn't teach me, I don't know.
No, dude, gravity affects everything at the same rate. Especially if 2 things are the same shape, they'll both have equal air resistance, they'll hit the ground at the same time. Watch.
I don't believe it.
Okay, watch.
Prove it, man. Prove it.
See? They both hit the ground first.
Oh, wow.
You want to see it again?
Yeah. I wish Walsh taught us.
You could even do it with a bowling ball. It wouldn't matter. Bowling ball and ping pong ball. They both hit the ground at the same time. One go.
Newton has 3 main laws regarding about physics. His first law is that an object at rest will stay at rest, and an object in motion will stay at motion unless an outside force acted on it. This is a great example of Newton's first law. As you can see, the volleyball will stay in motion unless an outside force acted on it. And that outside force is unique.
Centrifugal force is an apparent force that pulls on an object that's moving around in a rotation, such as water in a bucket. We know that if you were to take a bucket of water and put it upside down, all the water would spill out. But because of centrifugal force, we can put it upside down and it won't spill. And we can rotate it around and it'll stay in the bucket at all times, like this. But if I stop and go slow, all the water spills out. Isaac Newton's second law is force equals mass times acceleration. With that, we know that if we take something with a decent amount of mass, like a soccer ball, and make it accelerate really quick, it can produce a lot of force. And here's a great example. With this soccer ball, we can break this piece of wood.
Wow, Timmy, that was really cool.
Alright, so if you take something like an orange and try to pierce through it with your fist, it doesn't really work that well. Because my fist has a relatively high amount of area with a relatively low amount of pressure. But if we use that same amount of pressure and use something that has a lower area, like a knife, it pierces right through it. No problem. And then, we got a delicious snack after.
As you can see here, Newton's third law states that each force has an equal but opposite reaction. So here when I hit the nail, some of the force goes into the nail, but some of the force also comes back up, forcing the hammer to come back up like that.
Alright, so another thing in physics is simple machines. Another great simple machine is a wedge, which helps you, such as an axe, which can help you cut through wood. Here, I can try cutting through a potato with my hand. Doesn't work. Now, if we try it with an axe, it'll most likely work. We'll just keep trying until we get it.
Just cut it right there.
Did you get that?
Yeah.
Yeah. See, now we got the simple machine cut this potato clean in half. Not like my hand though. The wedge took the job right. Energy is another great example of physics. A refrigerator is something that uses thermal energy. Heat flows spontaneously from a warmer object to a colder object, which is done in a refrigerator. It uses the mechanical work to do this. Electrical energy runs a motor that does work on a gas and compresses it. The gas draws heat from the interior of the refrigerator, passes from the compressor of the refrigerator, it cools into a liquid. Thermal energy is transferred into the air in the room. Liquid in the interior then vaporizes it and absorbs the thermal energy in its surroundings. There's also electricity, which is also physics. It does some stuff and it's physics. And then we got fire. Alright, well, our slide is an example of physics as well. There's friction involved. And since me and the slide have a low coefficient of friction, I go down very smoothly. Like so. Nice and fast. But something like cheese doesn't have a high coefficient of friction and doesn't slow down, or doesn't, go down. It just sticks.
Stupid cheese. It's because you didn't use Bernoulli's principle. What the hell is wrong with you? When I give you the thumbs up.
Okay.
Start again.
Centrifugal force is the apparent force of.
You can see here in Newton's third law that each force has an equal but opposite reaction. So therefore when I hit the hammer, when I hit the nail, it comes back up and bounces back up like a third reaction. And some of the...
Another great example of physics is in bicycles. Bicycles. Come on. Alright, so a refrigerator is another example of physics. Both. God damn it. Alright, thermal energy is another example of physics. And someone that uses this is a refrigerator. Heat will flow spontaneously from a warm object to a cold object. However, it is possible to remove the thermal energy from a colder object and add it to a warmer object if work is done. A refrigerator is a great example of this. It's a common device that accomplishes its transfer with the use of mechanical advantage, or mechanical work. Electrical energy runs a motor that does work on a gas and compresses it. The gas draws heat from the interior of the refrigerator, passes from the compressor through the condenser, coils on the outside of the refrigerator, and cools into a liquid. Thermal energy is transferred into the